Every year, countless patients face a difficult recovery after surgery, especially when wounds make sitting painful and complex. We are Lattice, and this is our custom 3D printed cushion. Wheelchair users face a high risk of pressure ulcers because of prolonged sitting, limited mobility, and often reduced sensation. Add in poor posture and an ill-fitting cushion, and you've got a dangerous situation. Pressure ulcers often form at the ischial tuberosities, the sacrum, the trochanters, or the tailbone, the body's pressure points when seated. With that, our objective was simple: design a cushion that offloads pressure, custom fit to each patient using 3D printing and parametric modeling. There are 4 key steps in our process: scanning the patient, creating a 3D model, printing the cushion, and assembling it in the final product. We scan patients in the prone position. This lets the tissue relax naturally, helping us get an accurate contour of the body. That ties directly into our goal, which is evenly distributing the pressure while avoiding bony areas. The 3D scan is then imported into SolidWorks and converted to a cushion by modifying its outline and adjusting its offloading zones based on pressure points. We tested 3 different methods to offload pressure: removing material, adding material, and variable infill. To remove material, an ellipsoidal cut is made, whose parameters are given based off of the patient's wound size and location. This changes for every patient. When it comes to adding material, a trapezoid-like structure is added to the back of the patient, intended to push the patient up and away from the wound. Lastly, by varying the infill density of the cushion, we're able to create a low and high pressure region that is able to offload the wound. In our case, with our cushion being 8% infill density, we create a 7% density region around that wound area in order to offload it. The cushion is then sent off to the 3D printer and printed in 3 separate parts using 85 ATPU and a gyroidal infill pattern. Each part takes about 11 hours, so we optimize the process with 3 printers running at once. Once the 3 different parts are printed, they are then bonded with a high-strength custom-made adhesive that's about 85% THF and 15% TPU by weight. The TPU is dissolved in that mixture, and then the solvent evaporates. This creates a glue that's a lot more flexible than commercially available options. Once glued, bonded seams are created, which are more rigid than the surrounding structure. This has the unwanted effect of causing a pressure point, which can lead to further pressure ulcers or unwanted sitting postures. For that reason, squiggly lines are selected for printability, with overhangs less than 45 degrees and an increased surface area. Additionally, we left a centimeter off the top unglued so we can have maximum compliance and no feeling in that area, with little to no pressure points being created. Now that the custom 3D printed part of the cushion is created, it's now time to assemble the foam components with the rest of the project. This is done using industrial grade Velcro and connected at the base of the cushion. To ensure that our cushion lasts the whole of the recovery period of the patient, the base was sent to get compression tested, fatigue tested, and compression tested again for before and after. With careful design, we created a fully customized cushion to prevent and relieve ulcer wounds. We are Lattice. Let us see you at table R18 at the Capstone Expo.
Lattice.